Okay, so we're looking at the discriminant. That's what that symbol there, delta, means, or the triangle, if you want to call it, the discriminant. The discriminant is equal to this, b squared minus 4ac. It comes from the quadratic equation itself, but as far as you're concerned, you get a question to do with the discriminant, then you use this. Alright? So the question could be, determine the roots of the equation, and you're given an equation. So there's a key word to look out for. If it asks you to determine the roots, we are thinking about our discriminant. What we need to do, we need to first of all identify a, b and c. A is the coefficient of x squared, which in this case is 1. B is the coefficient of x, which in this case is 6. And c is the constant, which in this case is 9. We then put it into our discriminant, which is equal to b squared minus 4ac. So we have 6 squared minus 4 times by 1 times by 9. So we end up with a discriminant that is 36 take 36. Our discriminant equals 0. Now, this small bit of working out gets us to our first point that we have to interpret. And that is, our discriminant is equal to something. You only ever get 3 options. 0, positive, or negative. What value it actually takes is neither here nor there. It's either positive, 0, or negative. That's all you care about. Alright? There's a small extension to the positive part, but for now, just focus on it. At the moment, it's popped up as 0, which means it falls into this category. Alright? So if you are trying to determine the nature or the roots of the equation, you are first of all working out what is the discriminant. If it's 0, it has one repeated root. It has one repeated root. I'll show you the diagram of that in a moment. So the answer to this would be, determine the roots of this equation. You'd show this working, and your answer would be, it has one repeated root. Okay? If it was positive, we would say it had 2 real roots. And if it was negative, we would say it has no real roots. Okay? There is a small extension to the real roots element. Alright, but I'm going to do that in a different example, so I don't want to get confused. This is the most important part. You have an equation, you put in your a, b and c to this equation here, the discriminant, and whatever value pops out, it doesn't matter if it's negative 120 or negative 1. If it's negative, you've got no real roots. It doesn't matter whether it's 1, 0.5 or 367. If it's positive, it's got 2 real roots. And if it's 0, it's got 1 repeated root. Alright? Okay, there's diagrams that we need to be familiar with. If it is negative, that means it has no real roots. And if we were to draw a diagram, or you had to choose from a diagram, if it has no roots, that means the parabola doesn't cut the x-axis anyway. Because roots are solutions where it cuts the x-axis. So it's drawn somewhere in the air like that. Or maybe it's down here. Or maybe it's upside down there. The point is, it never cuts the x-axis. Alright? If it's 0, it has 1 repeated root. I say repeated because quadratics always have 2 solutions. A repeated root means it touches the x-axis in one spot. So it is usually like that, or maybe like this. The point is, it only touches the x-axis at one point, because it has 1 repeated root. Okay? In this example. And if it's positive, it has 2 real roots, which means it's going to look like a very normal quadratic, things you're used to. See how it cuts it twice? Or like this. See how it cuts it twice? It doesn't matter which way up the parabola is, whether it's positive or negative, smile or sad face. All you care about is the value of the discriminant to tell you which one it is. Alright? You've got to separate the discriminant to what the actual parabolas look like. Alright? This extension here, boys, I do want to go into it. Say if my discriminant was equal to a perfect square. So an example of that would be 36, or 49, or 25, or anything like that. If it's a perfect square, if the positive number happens to be a square number, you actually say it has two real rational roots. Alright? Rational roots. If it is any other positive, so any other number, so that's not a square number that's positive, we would say, so the discriminant say is equal to 15, we would say it has two real irrational roots. Okay, so that's the extension part. That's all within the positive element.